Alrighty, round three for this weekend. I'm going to take a look at, we're going to take a look at rhombus and squares. So let's go ahead and get started. Now, for rhombus and squares, what we are dealing with here is very special properties of the special parallelograms in that now we have all sides are equal. This is one of the main things. Diagonals are perpendicular is another huge difference between the two. So all sides are equal and diagonals perpendicular. This is a big deal. The other neat thing right here is the diagonals bisect the angles. This is going to be huge in the difference between a rectangle and a rhombus and a square, so on. First example. So what we're going to do is just basically apply. Here we have a rhombus, all right? Go ahead and circle rhombus when you see it on a problem so you know what you're dealing with. That means all four sides angles, these things bisect, and so on. So ST is right here, and we're going to call this 13. Okay? That means this is going to be 13 also, not this. The diagonals are not congruent on a rhombus. This one has to travel further than this one. But they do bisect the angles. So SQ is going to be the whole thing. That's going to be 26. So boom, 26. PRS is 17. Here's PRS. So this is 17 right here. Guess what? This is going to have to be 17 also. Over here is going to be 17. Opposite angles are congruent from parallelogram. So if this is 34, this has to be 34. And since they bisect, they're both 17. So QRS is going to be 34. Okay? That's a 4. Promise, promise. STR. Find the measure of STR. STR. Another property is that since these are perpendicular, this is going to be 90. And let's take a look at this last one. Let me erase all this. So we got SP is 4x minus 3. So SP is 4x minus 3. And PQ, which is right here, is 18 plus x. Oh, that's a plus sign. Now, all sides are congruent, so we're just going to put 4x minus 3 is equal to 18 plus x. Subtract x on both sides, that gives us 3x, and then add 3, so we get 3x is equal to 21. X is equal to 7. This is a real quick just review of some of the definitions of a rhombus. Again, these are perpendicular right here. These bisect. That's a huge definition. The diagonals are not congruent because this puppy leans. Now we're going to look at squares, and squares are not quite the pain that some people label them. I think they're actually easier as long as you're somewhat familiar with the isosceles 45-45 right triangle. Now, what we have is pi is 24. So here's 24. This whole thing is 24. And given the properties of a square, they bisect each other. So I know this is 12 and this is 12. All right. And we also have right angles here. We have right angles over here. We got all kinds of right stuff going on. So this whole thing's 24. This, we're looking for IN. So what we have is the hypotenuse of 24. Let me put it right here. So here's 24, and we're looking for this. I'll call that A, and this is also A, because we have a right angle. So the hypotenuse of a 24 is A radical 2 as well for our special 45-45, because these are all 45. Remember, these bisect because they have the properties of a rhombus, so this bisects here. So what we do is just simply put 24 is equal to A radical 2. So when we solve 24 is equal to A radical 2, we divide by radical 2. We have A is equal to 24 over radical 2. When I simplify that real quick in the calculator, because when you're doing it on a test, you don't need to... Yikes! Boy, I'd better use something else than my pen here. So I got 24 divided by shift radical 2. Okay? And these sides are all nothing more than 12 radical 2. There's shortcuts to this. So this is 12 radical 2. Okay? Think about this half times radical 2 if you want to think of it in a short way. Now let's go ahead and erase all this, and we're going to look for AI is now 18. Now this gets a little bit more interesting, but it's still a special right, isosceles special right. So here we are. So AI is 18. Here's my right angle right here. So here is my hypotenuse again. So I have 18. And here are my two sides. So here's A and A again. We're dealing with a smaller right triangle. So this is 18. So we know this is going to be 9 radical 2 because you're just going to set this 18 equal to A radical 2. So I'm going to divide 18 divided by radical 2, shift radical 2, enter. And I need to hit enter. There we go, 9 radical 2. Okay, so this side right here is 9 radical 2, this side is 9 radical 2, this side is 9 radical 2, so on. So this whole thing right here, Tn, oh, this right here is 9 radical 2. So we're not looking for the whole thing. We're just looking for this part right here, 9 radical 2. Measure of API. API, we know that all these bisect. If this is 90, it bisects, it's 45. So on. They're all 45, 45 rights. Okay, so that wraps it up for squares and rhombus basic examples. I may have some more complex ones later on.